Today we are going to discuss one of the most powerful concepts in modern analysis, that is fixed point theorem. Okay, and first of all we define fixed point. What is fixed point? A fixed point of a function f is a point x. What is fixed point? A fixed point of a function f is a point x such that fx equal to x. Okay, now geometrically we can understand, if you plot y equal to fx and y equal to x, if you plot y equal to fx and y equal to x, the intersection, geometrically we can explain like this: intersection point give fixed point. Okay, now we'll take an example. Let's take, this is y equal to, let's take y equal to, this is y equal to x, and let's take an here. Okay, so these 2 points are fixed point, and this is the graph of x square equal to y, and this is y equal to x. Now x square equal to x square minus x equal to x, you can see x minus 1 equal to 0 and x equal to 0 and x equal to 1. So in y equal to x square, 2 fixed points are x equal to 0 and x equal to 1. You can see, if x equal to 0, y equal to 0, and if x equal to 1, y equal to 1. So there are 2 points, fixed point. By this we can explain it geometrically. Now why are fixed point important? Okay, next point is why fixed point are important. So important. Okay, number 1 point, fixed point provide guarantee for the existence of solution. Fixed points provide guarantees for the existence of solution. Okay, solution. Why the fixed point are important? First, it guarantee for existence of solution. Okay, second we take, they help in iterative methods. They help in iterative methods. Many algorithms converge to fixed point. Okay, and now most important, second, what I'm saying, they help in iterative methods. Many algorithm converge to fixed point. Okay, now we can also say used widely in solving differential equation, integral equation, optimization problem, even economic and game theory. These are the basic importance of fixed point: solving differential equation, solving integral equation, solving optimization problem, and even economics and game theory. In these all area, fixed point are important. Okay, now we will discuss very important fixed point theorem, that is Banach fixed point theorem. Banach fixed point theorem. Okay, first, what is the Banach fixed point theorem? If XD is a complete metric space, this is complete metric space, okay, and fx to x is a contraction mapping. Okay, what is Banach fixed point theorem? If XD is a complete metric space, okay, and fx to x is a contraction map, d fx comma fy, distance of fx and fy will be less than equal to c dxy. What is this? For all xy in belongs to x. Okay, and some c is greater than 0 and less than 1. This for all xy in x and some c greater than 0, 1. Then what is the result of this theorem? First one is f has a unique fixed point. F has a unique fixed point in x. If all these conditions are satisfied, then f has a unique fixed point in x. Second, starting with any initial point x0, the sequence defined by x n plus 1 will be equal to f xn. Okay, converge to that fixed point, converge to that fixed point. I am also again repeating this Banach fixed point theorem. What is Banach fixed point theorem? If XD is a complete metric space. So what is complete metric space? Okay. If XD is a complete metric space and F X to X is a contraction mapping. Contraction mapping, I think these all definition, complete metric space, contraction mapping, you have to aware about these definition. Okay. Contraction mapping for all x, y in X and some C greater than 0 less than 1, then what is results are, first result is F has unique fixed point, okay, and second result, starting with any initial point x0, the sequence defined xn plus 1 equal to F of xn, okay, converts to that fixed point. Now we will take some example and application. Now used to prove the existence and uniqueness. Application, you can say application of Banach contraction theorem used to prove the existence and uniqueness of solution for ordinary differential equation. This is useful for, because here you can see F as unique fixed point. You can see na, in result Fx unique fixed point. Then the application is, number one is used to prove the existence and uniqueness of solution. Okay. Now used in solving integral equation, and third in numerical analysis, iterative method like Newton-Raphson rely on the idea that you get closer to a fixed point. Okay. Now